The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so we're going to start to wrap up the last section of chapter 5. We've looked at addition and subtraction of polynomials, multiplication of polynomials. What's left? Division of polynomials. So that's what we're going to look at today. First of all, we're going to deal with a case of where we're dividing a monomial by a monomial. And this is actually just a review of what we did in section 5.2. So let's say, for instance, we have a to the 12th power divided by a to the 8th power. We're dividing two powers with the same base, so we subtract the bottom exponent from the top exponent and attach it to the common base. 12 minus 8 is 4, so the answer, a to the 4th power. Let's say we have 22 b to the 9th power divided by 6 b to the 6th power. Well, first of all, I can reduce the 22 over 6 to 11 over 3. B to the 9th divided by b to the 6th would be b to the 3rd, so I get 11 b to the 3rd over 3. You could also write this 11 thirds b to the 3rd power. Just be careful that you don't do this and let this thing get down below the fraction bar. All righty. Let's say we have negative 4x cubed divided by 16x to the 5th power. So then this becomes, let's see, negative 4 over 16 would be negative 1 over 4. X to the 3rd divided by x to the 5th would be x to the negative 2 on top. But we could move that down below and make it into x to the positive 2 power. Any questions about that example? Okay. Let's say we have 16y cubed over y to the 4th power. Y cubed over y to the 4th would be y to the 3 minus 1 power, or y to the negative 1 power. So we end up with 16 over y to the 1 power, or just 16 over y. All right, now that's just a monomial divided by a monomial. And as I say, that's kind of what we did back in section 5.1 and 5.2. Now we're going to look at a case where we have a polynomial. So basically a binomial or larger divided by a monomial. So let's say, for instance, we have the following: 6x plus 3 divided by 3. Now, there might be a temptation to do this and say, oh, it's 6x plus 1. But this is wrong because we can't divide that out because up on top here we have terms. If we had 6x times 3 over 3, then we could reduce it down because these are factors. But when they're terms like that, we can't reduce it this way. So what can we do? What we do is we take each term in the numerator and divide it by the term in the denominator. Okay, and then we go back and reduce each thing. So we get 2x plus 1. Any questions about that example? All right. Let's say we have b squared plus b cubed minus b to the 4th power, all divided by b to the 4th power. So we have a polynomial divided by a monomial. We take each term of the numerator and divide it by the term in the denominator. And then we go back and we simplify or reduce each separate fraction. So b to the 2nd over b to the 4th would be b to the negative 2 on top, or 1 over b to the positive 2 on the bottom. Trying to make my b's not look like sixes. B cubed over b to the fourth is b to the negative 1 on top, which would be plus 1 over b to the 1 power, or just b. And then finally, minus, well, b to the fourth over b to the fourth is 1 over 1, so minus 1. So this would be your final answer. Again, note, we want to write our answers so that there's no negative exponents. All righty, let's take a look at this one. For x to the 14th power minus 36x to the 8th power over 36x to the 12th power. So once again, we have a polynomial divided by a monomial. We take each term in the numerator and divide it by the term in the denominator. So I get 4 over 36 reduces to 1 over 9. X to the 14th over x to the 12th is x squared. So I end up with x squared over 9, or you could write it as 1/9 x squared. Either way, let's see what they did. They wrote x squared minus or over 9, but either way, okay? And then minus, let's see, 36 over 36 is 1 over 1. X to the 8th over x to the 12th is x to the 8 minus 12, or x to the negative 4 power. So now I have 1 over x to the 4th. And again, so I could write it this way or that way. Okay. And let's see here. Negative 25 x squared y cubed plus 30 xy squared minus 5xy, all divided by negative 5x squared y squared. So we have a polynomial divided by a monomial. So we're going to take each term in the numerator and divide it by the term in the denominator. Let's see here. Don't forget that negative sign. And then let's see here. And there. Okay. So going back and reducing each separate fraction, negative 25 over negative 5 would be a positive 5 over 1. X squared over x squared would be x to the 0 power, or just a 1. And y cubed over y squared would be y. So I end up with 5y. Okay. Next term, let's see. 30 over negative 5 would be negative 6 over 1. X over x squared would be x to the negative 1. Y squared over y squared would be 1 over 1. So now I've got what? Plus negative 6 x to the negative 1, all over 1, which I could write as minus 6 over x. Are you okay with how I got from there to there? Any questions there? I'll take that as a no. All right.
No, I'm a little confused on that one.
Oh, okay, okay.
My mic was off.
All righty. So let's go back here. See if I can. Okay, so we've got 30xy squared over negative 5x squared y squared. Let's take it a piece at a time. This piece, 30 over negative 5 would reduce to negative 6 over 1. Are you okay with that?
Yes.
Okay. This piece, we've got x over x squared. So that would be x to the 1 minus 2, which is x to the negative 1 power.
Mm-hmm.
And then, that doesn't show up very well here. Let's see. Let's go back to black here. y squared over y squared reduces down to 1 over 1.
Mhm.
So what have I got now? I've got plus negative 6x to the negative 1 over 1. Okay? You all right with that so far?
Yes.
But I could take this and write it as minus 6 over x, because plus a negative is like subtracting, and x to the negative 1 on top would move downstairs and be x to the positive 1 down below, but I don't need that. Oops, negative 1 for that positive 1 exponent down below.
Okay.
Okay, all right, excellent. Next expression. Well, we've got a negative and a negative there, so I could make that into a positive. You okay with that?
Yes.
5 over 5 is 1 over 1. X over x squared is x to the negative 1, because 1 minus 2. Y over y squared is y to the negative 1. So now I've got plus x to the negative 1, y to the negative 1, which is plus 1 over xy, because it would be 1 over x times 1 over y, which is 1 over xy. So then here's my final answer.
Okay.
All righty. Well, that was the warm-up exercises. Now comes the fun stuff. Now we're going to look at dividing a polynomial by a polynomial. Okay. Now, before we do that, let's review long division in terms of arithmetic. Let's say I've got 843 divided by 7. Okay. So the first thing you do is you say, well, does 7 go into 8? It goes in one time, so we put a 1 there, right? And then we go 7 times 1 is 7. We put it right there. We draw a line, and then we subtract. And some of us may have been taught to put the minus sign. Some of us were taught that, well, you just assume it, either way. I'm going to go ahead and put it there. So 8 minus 7 is 1. Since this is less than that, then I know that I've done that step correctly. And I start all over. I bring down another number. 7 goes into 14 twice. 7 times 2 is 14. 0 remainder. Bring down a 3. 7 doesn't go into 3, so I put a 0 there. Now, back when you first learned arithmetic, you'd write R3, remainder 3. Do you remember that?
Yes.
And then things got more advanced, and we wrote it as a fraction, 3/7. So basically the remainder over the divisor. And this is the form we'll be using for our polynomial division.
Okay.
Okay. Now, what we're going to do is similar, but there are a couple of discrepancies. So we'll talk about those. Let's say we have the following. It says divide x squared plus 8x plus 12 by x plus 2. Now, if we wrote that as a fraction, it would look like that. But if we wrote it using long division, it would look like that, okay? And that second one is the form we're going to be using. Now, first of all, I want the dividend, the number that's inside, to be in descending powers. And it is x squared plus 8x plus 12. I also want the divisor, the quantity outside, to be in descending powers. And it is that as well, x plus 2. If it wasn't, we'd move things around to make it so. All right. Now we're going to focus on the leading term inside and the leading term outside. We're going to take the leading term inside and divide it by the leading term outside. X squared divided by x would be x. which we're going to put up here in the appropriate column, because that's the column where the x to the first power goes. Okay.
Okay.
Then what do we do next? We take this times all of that, right?
Mm-hmm.
So we'll take x times x plus 2, which gives us x squared plus 2x. We write that over here. Then we draw a line and we subtract, but be careful. We're subtracting that entire quantity, not just the first term, okay? So we're subtracting the quantity. The next thing I'm going to do, and this goes back to something we did several days ago, and I said it's getting us ready for something that's coming. Well, here it is. We're going to take subtraction and change it to addition of the opposite. So basically, I changed subtraction to addition outside, and then I changed the sign of each term inside. Or another way of thinking of it is just distributing the subtraction sign, okay? Well, now that I've got a plus sign outside, I could, if I wanted to, drop those parentheses or ignore them and add it up. So what do I do when I add it up? Well, let's see. This is going to be 0x squared. This is going to be what? 8x plus negative 2x is 6x plus 12. And in fact, I probably wouldn't even bother to write that since it cancels out. So I get 6x plus 12. Mm-hmm. Now we're going to start all over. We're going to look at the leading term inside divided by the leading term outside. 6x divided by x is 6. So I'm going to come up here and write plus 6 in the constant column. And then I'm going to take the 6 times the x plus 2 and get 6x plus 12. 6x plus 12. I'm going to subtract that quantity from what's up above. I'm going to change it to addition of the opposite and add them up. I get 0 and 0. So there's no remainder. So my answer is that. So basically, x squared plus 8x plus 12 divided by x plus 2 equals x plus 6. Now, let's say I've got 24 divided by 2, and I get a 1 and a 2, and the answer is 12. How do I check my work? Well, don't I take that times that, the answer, so the quotient times the divisor, and 12 times 2 is 24. So let's go back here. This times this should equal that. X plus 2 times x plus 6, x squared plus 6x plus 2x plus 12, x squared plus 8x plus 12. It's a good thing I can write beyond the white space there, huh? And yes. So, yeah. Okay with that?
Yes. All
righty. Let's say we've got divide x squared minus 5x plus 6 by x minus 3. So I've got x minus 3 on the outside, x squared minus 5x plus 6 on the inside. Again, inside and outside, they're in descending powers. I'm going to focus on the leading term inside, oops, I want it to be red, and the leading term outside. So I'm going to take x squared divided by x, which is x, which I'll put there. Then I'm going to take that x times x minus 3, which is x squared minus 3x, which goes there. I'm going to subtract that quantity from what's up above, but I'm going to change it to addition of the opposite. So changing subtraction to addition, changing the sign of each thing inside the parentheses, Now, since there's a plus sign out front, we can ignore the parentheses. X squared plus negative x squared is 0. Negative 5x plus 3x is negative 2x. And then bring down the next term, the plus 6. Start all over. Take the leading term inside divided by the leading term outside. Negative 2x divided by x is negative 2. So I put minus 2 up there. Then I take minus 2 or negative 2 times x minus 3, and I get negative 2x plus 6, which I put here. Draw a line, subtract that quantity from what's up above, change it to addition of the opposite. Negative 2x plus 2x is 0. 6 plus negative 6 is 0. So once again, no remainder in this case. The answer is x minus 2. To check it, x minus 2 times x minus 3 is x squared minus 3x minus 2x plus 6, x squared minus 5x plus 6, and it checks. So far, so good?
Yes.
Okay. Now, these first two examples had no remainder. That will not be true on this next problem. Let's see here. We've got 3x squared minus 8x plus 3 divided by 3x minus 2. So the 3x minus 2 goes outside. The 3x squared minus 8x plus 3 goes inside. Both of them are in descending powers. I'm going to take the leading term inside divided by the leading term outside. So I've got 3x squared divided by 3x, which is still just x, because the 3 is reduced down to 1. X squared over x is x. So I put an x there. Then I'm going to take that x times the divisor, the 3x minus 2. This becomes 3x squared minus 2x. So 3x squared minus 2x. I'm going to draw a line and subtract that quantity from what's up above. We'll change it to addition of the opposite. Again, change subtraction to addition and change the sign of each term inside the parentheses, which we can now ignore the parentheses. 3x squared plus negative 3x squared is 0. Negative 8x plus 2x is negative 6x. Bring down the next term, plus 3. And start the whole process over. Divide the leading term inside by the leading term outside. Negative 6x divided by 3x would be negative 2. So minus 2 there. So far, so good?
Yes.
All right. Negative 2 times 3x minus 2 is negative 6x plus 4, which we put there. We're going to subtract that quantity from what's up above. We'll change it to addition of the opposite. Add up the columns. Negative 6x plus 6x is 0. 3 plus negative 4 is negative 1. Ah, so that's my remainder. Now, what I'm going to do, I've got my answer, x minus 2, and then plus my remainder, which is negative 1 over 3x minus 2. Now, some books will write the answer that way. Some books will write the answer that way. You see what I'm saying there, doing there?
Yes.
They're both correct. In the textbook, they're doing it this way. I honestly don't remember if WebAssign cares, but you can try, experiment. Don't wait till the test to experiment, kind of thing. Yeah.
Okay.
All right. But I think I'm going to stick with this form just because that's what the textbook is doing. But technically, they're the same. All right. Let's take a look at this one. 4x squared plus 6x minus 1 divided by 2x plus 1. So we have 2x plus 1 on the outside, 4x squared plus 6x minus 1 on the inside. Again, both are in descending powers. We're going to take the leading term inside divided by the leading term outside. 4x squared divided by 2x would be 2x, which goes there. We're going to take 2x times the divisor, 2x plus 1, which gives us 4x squared plus 2x. So 4x squared plus 2x. We're going to subtract that quantity from what's up above, but we'll change it to addition of the opposite. 4x squared plus negative 4x squared is 0x squared. 6x plus negative 2x is 4x. Bring down the next term, the minus 1. Start the whole process over. Leading term inside divided by leading term outside. 4x divided by 2x is a positive 2. We take the 2 times the 2x plus 1, and we get 4x plus 2, which we write there. Subtract that quantity from what's up above. Change it to addition of the opposite. 4x plus negative 4x is 0. Negative 1 plus negative 2 is negative 3. So I get 2x plus 2 plus negative 3 over 2x plus 1. And there's my answer. Okay with that?
Yes.
All right. Now, let's take a look at this one. X plus 2 divided into 3x plus 2x squared minus 2. What's wrong here?
It's not in descending form.
Correct. So we rewrite it as x plus 2 outside and inside 2x squared plus 3x minus 2. You've got to do that before you start the process or things will be not good. Okay.
Yes.
So we'll take leading term inside divided by leading term outside. 2x squared divided by x, which is 2x. 2x times x plus 2 is 2x squared plus 4x. 2x squared plus 4x. Subtract that quantity from what's up above. Change it to addition of the opposite. 2x squared plus negative 2x squared is 0. 3x plus negative 4x is negative x. Bring down the next term. Start all over. Leading term inside divided by leading term outside. Negative x divided by x is negative 1 or minus 1 in that case. Negative 1 times x plus 2 is negative x minus 2. Subtract that quantity from what's up above. Change it to addition of the opposite. Negative x plus x is 0. Negative 2 plus 2 is 0. So no remainder. So our final answer, 2x minus 1. All right with that?
Yes.
So there you have it. Now, what's going to happen tomorrow? We're going to look at cases where there's terms missing. So like maybe this term isn't there or this term isn't there. And we'll talk about what to do with that. That's the last section that we'll deal with. And again, that's tomorrow. But that's all I've got for today. So I will be back at 1:15 this afternoon. I'll go ahead and stop the recording.